In this video example, we're going to use the guide plate to design to discuss line work and circles and how to save a drawing.
We're now going to work on some of the fundamentals of AutoCAD by creating a drawing called the guide plate. To do this, we're going to create a mechanical drawing using the different coordinate entry methods. The rule for creating CAD designs and drawings is that they should be created at full size using real-world units. Only when a printer or plotter transfers the CAD design to paper is the design scaled to fit on a sheet. The tedious task of determining a scale factor so that the design will fit on a sheet of paper is taken care of by the CAD system. This allows the designers and CAD operators to concentrate their attention on the more important issues, the design. To get started with this, we're going to select the line command. We will locate the starting point of our design at the origin of the world coordinate system. To do this, we're going to type 0, 0 in the command line and hit enter. Notice that the line started right at the origin point of the world coordinate system and is attached to our cursor via a rubber band line. We're going to create a horizontal line by entering the absolute coordinates of the second point, which is 5.5, 0. Select enter. And notice that the line we created is aligned to the bottom edge of the drawing window. We're going to adjust the view of the line by using the pan real-time command. To do that, we're going to go up to the menu bar and select View, Pan, Real-Time. This allows us, with our little hand cursor there that you see, to move the drawing around. So we're going to go ahead and drop it right there. Hit enter and notice that we are back into our line command. The available pan commands enable us to move the view to different position. The pan real-time function acts as if you're using a video camera. We can also use the scroll bars to adjust the view of the display. We press the escape key and exit the pan real-time command, and AutoCAD goes back to the line command. We're next going to create a vertical line by using the relative rectangular coordinates entry method relative to the last point we specified. To do that, we're going to enter at, we're going to use the at symbol, 0 units to the right, comma, 2.5 units vertically. We're going to press enter. Notice the line went straight up. It went 0 units to the right and 2.5 units vertically. If we left click once on this coordinates area down here, I want you to notice we can switch to a different coordinate display option. The coordinates display has changed to show the length of the new line and its angle. Each click will change the display format of the cursor coordinates. We want to set the display back to using the world coordinate system. We can mix any of the entry methods in positioning the locations of the endpoints. Move the cursor to the status bar area and turn on the snap mode. Note the line command is resumed, just as it had been before. We're going to create the next line by picking the location, world coordinates 8, 2.5. So with the snap mode activated, this becomes really easy. 8, 2.5. We're next going to use the relative polar coordinates entry method. The distance is 3 inches with an angle of 90 degrees relative to the last point we specified. We're now going to enter at 3 less than 90 and hit enter. You'll see that the line went straight up 3 units at 90 degrees. With the polar coordinate system, 0 is to the right, 90 is vertical, 180 is to the left, and 270 is straight down. Using the relative rectangular coordinates entry method, we're going to create the next line. We can imagine a reference coordinate system aligned at the previous point. Coordinates are measured along the 2 reference axes. To do this, we're going to enter at negative 1.5, 1. 1.5 units to the left, 1 unit up. We're now going to move our cursor directly to the left of the last point and use the direct distance entry method by entering 6.5. So it's going to go 6.5 units wherever the cursor is going. So you got to be somewhat careful in what direction or where your cursor's at. But I'm just going to type in 6.5 and hit enter. And you'll see that it did 6.5 units to the left because that's where my cursor was at. For the last segment of the sketch, we can use the close option to connect back to the starting point. To To do this, we right mouse click and a pop-up menu appears on the screen. Select Close, and you'll see that not only did it take the line back to the starting point, but it also ended the line command. Next, we're going to create circles. The menus and toolbars in AutoCAD are designed to allow the CAD operator to quickly activate the desired commands. In the Draw toolbar, we want to click on the little triangle below the circle icon. The little triangle indicates additional options are available. Notice the different options available under the circle submenu. Center radius draws a circle based on a center point and a radius. Center diameter draws a circle based on a center point and a diameter. 2-point draws a circle based on 2 endpoints of the diameter. 3-point draws a circle based on 3 points in the circumference. Tangent radius draws a circle with a specified radius tangent to 2 objects. And tangent draws a circle tangent to 3 objects. We're going to select center diameter. In the command prompt area, the message specify center point for circle is shown. AutoCAD expects us to identify the location of a point or enter an option. We can use any of the 4 coordinate entry methods that we talked about previously to identify the desired location. We're going to enter the world coordinates of 2.5, 3. You'll see the center of the circle is at 2.5 units to the right and 3 units up, and that the diameter of the circle is the same as the distance from the center point to the cursor, wherever that happens to be. To give the circle an exact diameter, we're going to type it in. So we're going to type in 2.5 for the diameter and hit enter. We now have a 2.5 diameter circle centered exactly at the 2.5, 3 location. To repeat the circle command, we're going to right click the mouse button and we're going to select repeat circle. Using the relative rectangular coordinates entry method relative to the center point coordinates of the first circle, we're going to specify the location 2.5 units over and 2 units up. To do that, we want to do @ symbol. That way it knows we're referencing the previous center point of the circle, and we're going to type in 2.5, 2 and select enter. And notice the center of this new circle is 2.5 units to the right and 2 units up from the previous center point. In the command prompt area, you're going to see specify radius of circle or diameter, and it's going to have 1.25 there. The default option for the circle command in AutoCAD is to specify the radius and the last radius used. So inside the graphics window, we're going to go ahead and right click to bring up a pop-up menu, and we want to go down to diameter. Now you're going to see down there that specify diameter of circle, and then in the carets is 2.5. We're going to go ahead and press or type in 1.5. We want a little bit smaller circle, 1.5 diameter, and select enter. And you'll see that we get a circle that has a smaller diameter. The last thing we're going to do is save the CAD design. There's several different ways that we can do that. So we can go up to the application menu and go to save. That's an option. We can also type Control S and that will save it. Or we can go up here in the quick access toolbar and save it from there as well.